It's snowing outside. Thought I'd drop this on a Christmas beat. We'll switch it up later on, but we'll start off with this Christmassy beat. It all started in the spring of 1942. I had all the ideas and things I just needed a clue. In my physics class, I get help from Mosin, and I use the mechanics of projectile motion to get the bomb skipped over the ocean. But first let me explain how Barnes-Wallis used his brain to create some pain for the Germans. It's all about learning about how not to fail and be innovative. I practiced on a small scale before the superlative. Initially, Wallace had the mentality of an engineer. We can make it clear that our objective is to explore physics, and that winning the war is just an elective. But it would give us an upper hand to destroy the dam, crushing the heavy industry in Germany. Are we allowed to fail? No, we can, which is why the solution is important. The C taught me the 5-point method, starting from number 1. To find the problem, we need to blast through up to 7 meters thick concrete spanning over 3,937 square feet. Converted to the International System of Units, SI, the bomb must fly into 365.7 square meters, destroying a dam holding millions of liters. The bouncing bomb must not detonate when it makes contact with that leg. We need a bomb capable of destroying the dam while avoiding the torpedo nets. 2. Let's define the physics, which is broad, ranging from busting bombs to acrobatics. We encounter kinematics and dynamics on a daily basis, but today the focus will be projectile. In order to eliminate the hostiles, we can't use the range formula because the bomb doesn't transfer over a level plane. But if we pay attention to the bounces as an individual, the displacement is 0 in the vertical. As with most problems in projectiles, the common style is to split the problem into its X and Y components. In the Y direction, the plane must be flying at 150 feet. In the X direction, the angle from the horizontal must be approximately 20 degrees based on calculations by French physicist Frédéric Bouquet. Outline a strategy, since there are no planes capable of carrying the weight of a strong heavy bomb. Instead we must place it tactically with the assistance of gravity. Have the bomb flow straight down to the wall with high proximity at the wall of the dam. It will blast more bang due to the water cushion working in our favor, causing a tremor, an earthquake, except underwater flavored. Cylindrical shaped bombs will allow the plane to bear the load. The backspin on the bomb lets it hop like a toad. 4. Solves the problem in this column is where we use the Oppenheim mean famous 5 equation, relating velocity, acceleration, displacement, and the agent that's never negative, time always positive, unlike time. The source of success and fun lies in finding out how much force is required to burst the dam. And since we already have mass, we can use F equals ma, something grade 11's learning class. A problem of this size requires the completion of Operation Chastise. 5. Evaluate the solution. Well, obviously the Germans lost the war, and since the destruction of the dam account for a third of their power production and requires 100 tons of water to create 1 ton of steel, it would be very real to say the operation had been a grand ordeal, but definitely ideal. And since it allowed the Allies to steal the victory, forcing the Soviets to kneel at the wall of the dam, it will blast with more bang. I don't have any physical materials, but with the power of my words, I am going to paint you a diagram. Figure 1. The Lancaster bomber, flying 18 meters off the ground, uses a light in its tail and a light in its nose. When the two lights meet, it's 59.8 meters away from the sea. Figure 2. The pilot sees through a Y-shaped plywood device. There is no room to gamble, no dice, since percent error results in dead life. The bomb sights let the flyer know when he's 180 meters away by comparing the small pins on both of the trays. When they match with the towers, he lets go the power. It didn't break the first time, the sergeant looks sour, but ignore those jokes, physics always works, at least after a few tries. And some final notes: if you notice the bomb doesn't fly, the bounces get continually smaller, shorter, not taller, because there is energy loss due to the static friction when it's hitting, and definitely the force of gravity. This has made an influence on our culture. Imagine if the Germans won the war, we'd be in the gutter. In the end, the result was beautiful luster, thanks to the physics behind the dam busters.
DJ.